This is page 4 of the Matrices packet, and we're going to learn about determinants for this. Before you complete this part of the handout, you should work on assignment number 1 and finish that before you move on to learning about determinants. So first thing we're going to do is look at the determinant of a 2 by 2 matrix, which is a nice quick calculation. You just take the diagonals and multiply them and subtract them. So you start with the upper left and multiply by the lower right. So 6 times 3 is 18, and then subtract 4 times -1 is -4, and so the value of the determinant for this matrix is 22. So why don't you try that for 2 and 3, pause the video and then come back. So this one will be 16 minus a -12, or 28. And this one is -6 minus a -4, which is -2. So you're probably wondering why we care about a determinant and what they're used for, and you just have to wait a little bit until we get through the a little further. So for now we're just learning how to find the determinant, and then later we'll learn what it's good for and why we need it. So a 2 by 2 determinant is a quick, easy calculation. A 3 by 3 or 4 by 4 matrix, finding its determinant is much more involved. And we're going to go ahead and do it by example rather than try to read through this rule. It looks a little complicated here. A11 gets multiplied by the determinant of a 2 by 2 matrix, and then there's something going on with the signs, -1 to a power, -1 to a power, -1 to a power. Notice some things match here. When this is 1, 1, this is 1 plus 1. When this is 1, 2, this is 1 plus 2. When this is 1, 3, this is 1 plus 3. That's no coincidence. And then also, when this is 1, 1, if you kind of cross out the row and column that go with A11, then you get this determinant right here. And then A12 is this value. If you cross out this row and this column, then the remaining determinant is 2, 1, 3, 1, 2, 3, 3, 3. Same thing happens here. If you were trying to find the determinant off of this term, then this row and this column get canceled, and you end up finding the determinant of this. So like I said, we are going to practice that rather than try to get it all from this one little chart here. So first thing is to finding minors of a 3 by 3. This is just kind of part of the steps of finding the determinant. So for this one, we're supposed to be finding M12. Probably should have that written right here. So M12, the minor for row 1, column 2, is going to be the determinant of the remainder of the matrix. If we go to row 1, column 2, and cross out those terms, then the remaining matrix is -2, 1, 0, -9, and we know how to find the determinant of a 2 by 2 is just 18 minus 0, or 18. And then for this one, we're going to find M23, which means that you're going to find row 2, column 3, and cross those out, and then find the determinant of the remaining matrix. So 2, -1, 0, 6, and 2 times 6 is 12, minus -1 times 0 is 0, and so therefore 12. Alright, so that's kind of the beginning of finding the determinant of a 3 by 3. So here we're going to expand across row 1. You can pick any row to expand across. Most of the time it's nice to just go ahead and do row 1, but it's also convenient if you have any zeros to use a row that has zeros in it. And you could also do what's called expand across a column. We can look at that in a minute. So the first thing, if we're expanding across row 1, we're going to think of this row, and the first thing is a -1 raised to the, this 3 is in row 1, column 1, and so this gets raised to 1 plus 1, row 1, column 1. And then the determinant that I'm going to multiply by is what's left if I cross out row 1 and column 1. So it will be this, 6, 2, -2, 3. That's the first part of the determinant. Now I'm going to move on to this next term, and it is -1 and then 0. And that 0 is in row 1, column 2. So this gets raised to the 1 plus 2 power. And then if I cross out this column and this row, I'm going to use the matrix that's left, 4, 2, 8, 3. Obviously this whole expression here, this is going to be 0, but it's important to see the structure regardless. Then the next part of this determinant is going to be -1 raised to a power, and I'm going to use this -1 that's in the matrix. Now the power that goes here, this -1 is in row 1, column 3. And so what ends up happening is these outer coefficients here are alternating in sign. This 1 plus 1 is 2, so that -1 won't matter. 1 plus 2 is 3, so this will stay negative, and 1 plus 3 is 4, so this will turn positive. I'm going to cross out row 1, column 3, and use 4, 6, 8, -2. All right, and then it's just a matter of simplifying this. I would multiply these two together right away, so that will be 3, and then find the determinant of this, and you can probably just do it in your head. 18 minus a -4. This one is 0, and if we went ahead and found the determinant for practice, that would be 12 minus 16. That's a +1 times a -1. And this is -8 minus 48 is -56. So then this is 66 plus 0 plus 56, or 122. All right, so that is how you find the determinant of a 3 by 3 matrix. And interestingly, you can do the expansion. Here we just did the first row. Here we're going to say that we're going to expand across this column, just so that you can see what happens if you find the determinant for a 3 by 3 matrix and you don't use the first row, but you expand across this. I'll show you what I mean. So the pattern starts off the same, a -1 raised to a power, and the power, if this is my column that I'm expanding across, this is row 1, column 3, row 1, column 3. There's a -1 in that place. If I cross out row 1 and column 3, I'm going to use 4, 6, 8, -2 as my determinant. And it would be a great idea to pause the video and see if you can get the rest of this set up following the pattern that you've just learned. -1 raised to the, I'm going to use the 2 next, and that 2 is in row 2, column 3. And if I cross out row 2 and column 3, the determinant that's left is 3, 0, 8, negative 2, then a negative 1, and I'm on the 3 now. And that 3 is in row 3, column 3. So that'll be 3 plus 3 for the exponent there. And then if I cross out row 3, column 3, then I get 3, 0, 4, 6. All right, so simplifying this, that's the 4th power, so this will be positive, but that's negative. The determinant here is negative 8 minus 48, so negative 56. That's a 5, so this term is going to be plus a negative 2, since negative 1 to the 5th power is negative. This determinant is negative 6 minus 0, and that's going to be a positive 3, because 3 plus 3 is 6, so the negative 1 will become a positive. And this determinant is 18 minus 0. So now I have 56 plus 12 plus 54, and 56 plus 12 plus 54 is, ding, 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 122. And you can find the determinant expanding across any row or any column. Didn't matter which one I picked. If I had expanded across this one, then all these things would fall into place similarly, and you would get 122 as your determinant. These are just little problems to practice solving for an x value using your determinant skills. So, for example, here if I found the determinant of this, it would be 3x minus 4x equals 5. So negative x equals 5 or x equals negative 5. So if both of these values are negative 5, then the determinant will be 5. Solving this one, you have to set up all of this deal here, and after you solve it, you should end up with x equals negative 9 or x equals 0. And I will post the solution to this, but not take the time to put it in the video. So thanks for watching. I think now you can do the second assignment of the matrices. It's a bit shorter than the first one, so it should go quickly. You're just going to practice finding some determinants, and then also practice solving systems by changing them to reduced row echelon form matrices. Thanks for watching.